your previous work here, like 1 to 7, but let me look at 9. Let's get 2 right away. 4 more than the quotient of a number and 3 is at least 9. What do you think? You can say it out loud for me, then I'll write it. Yeah. What do you think? 4 more than...
Is it like 4 plus?
Yes, you got it. So I'll do it this way. When they say 4 more, I normally write it at the back, but you can write 4 plus. You got it. And then it's like 4 more. If you can think it like an additional 4, so you know how you write it in the back. But you don't have to. But you'll see why it's going to be kind of useful later on. Okay, now what about the quotient of a number and 3?
Would it be like
Quotient is division, but you could write it as a fraction. You know what I mean?
Yeah.
Do you want a number to be n? Let's use n. We can use x, but let's use n this time.
So would it be n over 3?
Yes, it should be. Let me double check. The quotient of a number and 3. Yeah, when they write it a quotient of whatever, first it will be the numerator, and then n, the next one will be denominator. 3. 3. Thank you. 3. Like that, right? You agree?
Yeah.
Right? Is at least 9. I'll do the rest. I just want to kind of dig your brain a little bit. Is at least 9. How would you write that as the inequality? Greater than, less than, how's that?
Would it be less than or equal to?
Let me see, less than or equal to at least 9. Okay, this could be the confusion the student sometimes experience, because it says less, least, less, least, but it's actually no. I'll explain. So it has to be at least 9, meaning that it has to be 9, at least 9 or greater. See, right? If you think about it, at least 9. That means 9 included, 10, 11. It makes sense if you kind of think about it. You get used to it. This is nothing. You got it. You got it right now. I know you got it right now. There it is. And then I think you're good to stop. But let's do it. Let me see. I know you did 11. I'll check that. Yeah, the wordings, the word problems I want to look at. Or this is not word problems, but more like set up phrases, verbal sentences, algebraic sentences, something like that. That's what they call it. So add both sides by 4. I'm going to write it. Subtract both sides by 4. Is that right? Let's do it. Subtract both sides by 4. I'll write it over here, what we have left. So it's from here. If and only if, it's like an arrow. Anyway, greater than equals to 5, like that, right? And then multiply both sides by 3, right? You can parenthesize it. You don't have to. There's no negative, nothing going on. It's just dot 3 it. So that cancel. It's like 3 over 1 here, okay? 3 over 1 here too. But you don't need to do that. And then you're left with n greater than 15. That should be the answer. Is that okay?
Yeah.
Okay. Now let me check your 11 right away. Negative 3 times a number increased by 7. Yeah, that's exact same arrangement I would write. Is less than negative 11. Yeah, you got it. Let me look at the steps. Yeah, subtract, divide. Yeah, looks good to me. And then you flip the arrow. Right? You got this. Yeah, very good. Good, dude. Very good. All right, let's do 13. 7 more than, here we go again. I would write 7, and then I'll, interpret the rest and put it in the front. You don't have to. I think many of you guys will do the 7 plus, but you'll see what I mean. This is going to be handy later on. It looks standard even also. All right, 7 more than 5. Oh, 5, 6, a number. 5, 6, a number. How do you write that? 5, 6 of a number.
So it would be like 5, like above 5, and then if I were 6, like times n.
You mean like 5 over 6, like this?
Yeah.
N? And then, yeah, I know how this. Yeah, 5, 6. 5, 6, yep, of a number. Of means multiplication, a fraction of times. Is that okay? Yeah, keep that in mind. In word problems also, sometimes they phrase it and you're like, yeah, you'll see it. Is more than -3. More than, no, not equals to, so more than -3. Okay, that's good. Okay, I'll leave this. I know you can solve it, but we'll come back to it. I want to go over the other page. There's tons. Let me double check. 7 more plus than 5, 6 of a number is more than -3. Yeah, that looks good to me. All right, let's see 14 here. 14, 4 times the sum of a number. 4 times. Oh yeah, let me see. How would you do this one? I'm sure you're okay, but 4 times the sum of a number
So it would be
and 2.
4. So then after the 4 would be in the parentheses.
Yeah. Oh, right. Great. Yeah. The sum implied grouping immediately. Difference implied grouping, but yeah, difference is going to be fancy here. The difference, yeah, or group. If it says something like subtracting, then it won't be grouped. We'll see. I think the way they word it. Yeah. Continue. N and 2.
Yeah, plus
Yes.
2.
2. Close parenthesis. Yeah. Close
Yeah.
parenthesis. I know, huh? I know. Yeah, it's closed. It's called parenthesis. It's like you want to continue. But when they say sum, it normally implies two things immediately. Unless they stretch out the wording, they'll rephrase it a little bit, like 3 numbers or something, sum of 3 numbers, and then they start stating, hey, there's blah, blah, blah. But when they say sum of a number and 2, immediately, just those two. Is that okay? Yeah. I know it's like, but I'm glad you're thinking it. Yeah. So yeah, you have to end the parenthesis. Now, increased by 3. I think you're okay. Add 3 like that outside. Yeah, it will make a difference. You cannot put it in the parenthesis, by the way. It will change everything. I think you know why, because you distribute the 4. You're going to have to distribute the 4 later on. It's at least, okay, tell me this one again. At least 27.
So it would be greater than or equal to?
Yes, greater than or equals to 27. Yeah, you got it. We'll come back and solve. I think you're pretty good with this. Oh, I should have made it a little smaller, but it's okay. I'll write the word elsewhere. Yeah, that looks good to me. At least 27. Okay, 15. The sum of 2. Okay, this one, I want to see what you've been taught, but I have no problem. I'll write it out if you have trouble. Tell me, what do you think? The sum of 2 consecutive even integers. Now, this tends to be more elevated, meaning that it's more advanced than typical, because you're supposed to learn the, like the layout for it. I'm sure your teacher gone over it. I think I've kind of laid out and demonstrate to you why, or show to you why it works. The way you set it up, consecutive. But let me see. What do you think you should do here? The sum of 2 consecutive even integers is less than 500. How would you write that?
So it'd be like x and then x plus 2.
Yes. Some people parenthesize the next one, but you don't have to. X. Oh yeah, okay, let's use x. No problem. Plus 2. It's really like this is the first one, this is the second one, right? Is that what you're saying? Yeah, you got it. But let me lay it out on this side here. The first one for even or odd. Even or odd. Let's have a look, okay? Even or odd. No kidding. Oop, how do you write it? Odd. But I'll write it vertically. Even or odd. It'll be the same. The first one, normally they write st and d, let x equals the first number. The second one will be plus 2, third, and so forth. N plus 4, right? Is that okay? N plus 4 is the third one. Is that okay, Alex? If you were asked to do 3 consecutively, 4, and then the fourth one will be 6, like that. Just the fourth one. Just want to show you that because you're about to deal with this later on. You'll be solving it and find them. I think we've done it. I think we've done it before, but I'm not sure. I forgot. Fourth, like that. Okay. And so forth. Okay. Now, less than 500. You okay? Just less than 500. Find the pair with the greatest sum. Okay. What that means is just solve it and you'll get the answer. But wait, when you get x, it's the first one. Is that okay? The second one, you add 2 to it. Yeah. When you get x, you write, this is the first, but then you have to add 2 to it to get the second. You don't forget to label that. Hey, let's do this quickly. Let's do this quick. 2n, let's combine like terms. Plus 2, you don't distribute anything because it's like a 1 in front of the parenthesis. Less than 500. Let's continue here. Subtract both sides by 2. I'm going over the wordings now below it, but I'm just gonna go ahead and put, I know you saw that, so it's gonna be 498 like that. Then divide both sides by 2. There's no flipping of the arrow or anything. There's no negative involved here. So half of this is what? Half of 400 is 200. Half of 90 is 45. Half of 8 is 4. So that's gonna be 249. That is your first. Oh, wait, what's happening? Did I made a mistake? Because it says 2 consecutive even integers. Even integers. So that's not even. Wait, what did I do wrong? Subtract both sides. Half of 90 is what? It is 45, right? Yeah,
Yeah,
right?
half and nine.
Hey, well, what's wrong here? The sum of 2 consecutive even integers is less than 500. Sum of 2, 1, 2, 2, 2. Subtract both sides. Yeah. Divide both sides. Yeah. Okay, I'll use the calculator even. Oh gosh. Wait, have you cut what I've done wrong? 500. Wait, 5. I don't see that. I just want to see my calculator. Where's my calculator? Right, over this side? Oh, no. Come on, show me the calculator. Let me close this out. Sorry. Okay, look at the work for me, okay? While I try to navigate the technology here. Gosh, come on. Let me go there, here, bring in the calculator here. There you go. Right. So 498 divided by 2. 249. Okay, something's wrong here. Find the pair of the greatest sum. What's wrong with it? Sum of 2. Well, guess what? It's in inequality. So let's go with it. Why am I changing it to n? So it's x, right? Make sure it's x. It shows x. So I'm sure I did it right. Let's continue with it and see what happens. Okay, so it's gonna be 249. Okay, fine, 249. And then what? 249. X is less. Okay, I see what's going on. This is actually quite elevated. Think about this for a second. Let me see why my opacity went down. I have no idea why I keep touching things. And that's the size of the. That's the size. Let me, right there. Okay, I get it. You solve normally, right? This is what happens, but you have to interpret it, right? So it says X less than. It means you don't include 249, right? You have to choose the number that is actually even below 249. You get it? That's why I want to work on this one. So that means the first X got to be, and then we'll test it. The first X got to be what? The first number. Let's label the first 248, right? Right? Yeah, it's less than 249. That's your first. Now the second one should be again got to be less than. So I'll choose X. I know it's +2. We want to plug it back in, but we can't. If we +2 it becomes 50. Get it? So we have to go below that. It's not a big deal. We chose the setup the way you were taught and you did it. So it's not a big deal. But then when we choose or make sense of the answer, here's my second one, okay? Then you got to do what you need to do. So it's going to be 246. I hope you're okay with that. Wait, or 250. Wait, let me double check. Oh, no, I take it back. The original problem says less than 500. I apologize. We're not looking at this step. We're supposed to look at the original, dude. Okay, put your thinking cap on, including myself, right? That means you can do it. You can pick 240, no, 250, 250. Okay, all right, breathe and tell me if you're okay with this. Yeah? The first number, now going by logic, x less than 249, that's nothing to do with 500. The first number, the x, got to be an even, so you have to choose it, 248. Got it? And then the second number, we'll add 2 to it. Why can you? Well, that's the second number. This is the first number. It has nothing to do with the x anymore. So the second number is x plus 2. Sorry, let me write it out so you know exactly that I'm doing that. Can I erase it with that? Nope, I cannot erase without the white spot. So okay, fine. I'll go back to that. So it's really the same thing as x plus 2 here, okay? Because you laid it out exactly that. Why can't I erase it? Oh, goodness. So don't ignore what I just did here, okay? So it's going to be x plus 2, which is going to be 248 plus 2. If you want to show that, it's going to be equals to 250. So these are your two numbers. And you want to check it, you're fine. You can add them. You know it's going to be less than 500, right? That's the proof. It's, what is that? 498, right? Yeah, that's why these works. That's it. These are the answers. 248, 250, less than 500. Add up to 240, add up to 240, add up to 298, less than 500, which is less than 500. Done. All right, I think we better do the other ones. Okay, I hope you're good with that. 6. Of all pairs of consecutive odd integers whose sum is greater than 80, find whose pair such is least. I think that's what it says. Yeah. Okay, well, what do you think about that? Consecutive. Consecutive odd. Isn't that the same thing, right? Consecutive odd and even, right? X plus 2. Did I prove that? Have I proven it to you, right? I plug in numbers and you get odd, right? Yeah, so they're the same. Okay, so it's going to be x plus, right? Whose sum. So it's kind of wording fancy, right? Whose sum. Same thing as like the last one. X plus 2. You don't need to parenthesize this, but it's greater than 80. Is that okay?
Yeah.
Yeah. Let's solve it also. Now we'll try to make sense of it. I think number 15 traumatized us. So we'll do this 16 and make sense of it, and I think the rest will be fine. Okay, so that should be it. So 2x plus 2 greater than 80. Subtract both sides by 2. So you're left with 2x greater than 78. And then if you divide both sides by 2, you're left with half of 70 is 35, half of 8. 35, half of 8 is 4. So it's going to be 42. Why is it 42? 39. 39. Half of 70 is 39. 70. What did I get 38 from? Half of 70 is 35. Half of 8 is 4. So it's 39. Greater than 39. Okay, then. We still have to make sense of it. Carefully. I think 15 triggered us to be reasonable here, right? Like, logical. Can we use 30? Can we use 39? You know, the two says, hey, find all pairs. That's implied two numbers. Okay. But right now, can we use 39, whose sum is going to be greater than 80? What do you think? The first consecutive odd. Can we use it?
Um. Yeah.
No. Here's why. You don't have the bar. There'll be a problem with the bar. Then we'll use it. Get it? Yeah. Like the greater than or equals to, something like that. So no, in
Yeah.
this case, that means you'll have to pick x to be equals to 41, not 40, because it's odd, right? Yeah. So it got to be 41. So your chosen number has to be this one. You have to choose this one. So let me go and check it. So you cannot use 39. It's odd, but you cannot use it because it says greater than 39, not including 39. That's why. So your first one, here's your first one. You could label like circle it, whatever. And the second one, you'll do x plus 2. You can show this work if you want. It's going to be equals to 41 plus 2, which is going to be 43. That is your second number. Yeah. So you don't have to circle x equals. You can circle the 41 not part and then 43, so it looks consistent. Consistent. I don't know. That's up to you. So the numbers got to be 41 and 43, and it will be true if you add them. It will be greater than 80. Simple, right? Simple. Yeah.
Yeah.
Done. And there's more. If you add them, right, it's going to be 84, which means that it's going to be the least sum that is going to be greater than 80. Let me see if you understand that. If you read the part where it says find the pair whose sum is least, it means like the least sum that is going to be greater than 80 with two consecutive odd that you can find. This is the most like things going on, right? But it's exactly that. If you may not have to worry about it as long as you get the two numbers. You should be fine. But if you wanted to make sense of the whole thing, find a pair. Some students are that critical, right? They wanna ask. You're probably asking right now, what does that mean? Find the pair whose sum is least. It means that these two combined will add up to be the number that is greater than 80, but the least you can get. Is that okay? Yeah. That is greater than 80. So therefore, try not to get like a 95 or whatever, right? You add up because they want the least near 80, greater than 80, but near 80. It's the way it is, I know it's like, it's a little confusing, but again, you don't have to worry. Just get the two numbers, but interpret it starting right here. Greater than 39, get your first one to be 41, and then your second one, 43. You're fine. Don't worry about the rest. It will work automatically. 99% of the time. So don't worry. All right. 17. Of all pairs, two, like, yeah, there's more. Okay. Yeah, I'm sorry. Let me go back to 16. It's pairs. I mean, you can have more, pairs, right? Like a 2, 2, 2, but again, we want the least. That's all they care for. So don't worry too much. Yeah. Don't think too hard about it. Like, there are more. No. Just that. All right. Continue. Of all pairs of consecutive integers, this time it's consecutive integers, not odd or even, whose sum is no more than 100. Okay, tell me, how would you write this one? Yeah, they're getting you to do every single thing now, algebraically. Algebraic. Yeah, algebraic, verbal algebra, interpreting everything now. 17, what do you think? How would you set it up?
So
You want to use
we
x? Huh?
x plus 1.
Okay, you mean x plus 1? Is that what you mean? Like that?
Yeah.
Yes. Is that okay? Okay, now how do you write the rest of it? No more than 100. No more than 100. Yeah, this could be
We
tricky
would,
again.
so no,
No more than 100.
would be less than or equal to.
Yes. Yeah, the part like you may hesitate to write is the equals to the bar. Yeah, but I know, huh? It's implied no more than one. I know this one could get the student, but it is grammatical. It is grammatical that it's if you ask an English teacher, yeah, it's 100 is part of it, right? No more than 100. It's implied that yeah, yeah, you can have 100. Yeah, that's it. You got it, dude. All right, let's solve it again. Sorry, I worry that it might be something fancy here. So let's solve it and see what happens here. Plus one when we interpret the answer, that's 100. Subtract both sides by 100. Subtract both sides by 1. So let's see what happens here. 2x less than or equals to 99. See, that's why we're doing this, because it's getting fancy. You want to know what's going on, right? So divide both sides by 2. It's 99 over 2. But here's the deal. These type of problems, right, they do not really want you to deal with fractions. If you kind of read through it, like 16, even before that, it's all about integers and things. You don't need fraction. The fraction will be a deterrent. However, a mixed number maybe not. Mixed number maybe not. But I would actually divide it, do long division, and get a decimal form of it. But it's not hard. You know why? Because if you divide anything by 2, it will terminate. The decimal will terminate. It won't continue on. So let's half 99. I don't know if you know it. If not, I'll use the calculator. But yeah, half 99. So you're getting a 0.5 out of it, So I'll use the calculator just, to be safe here, divided by 2. So I'll use this number instead of the fraction 99 over 2. Let's don't use that. So it's 49.5. Is that okay? But then we have to interpret that. What are we going to do with that? Or what do we keep it? Do we use it? Or what do we do? What do you think? So who's all pair of consecutive integers? What do you think? I know it says bar, but since the 49.5 is a decimal or even fraction, you cannot use it. Mixed number, whatever. So we cannot use it. So what do you think the first of the two would be? First consecutive even, yeah. We cannot keep the decimal form. We cannot use 49.5, even though we got the bar. Had it not been the decimal, we'll keep it. Yeah? But
Yeah.
what do you want to use this first one? Less than 49.5. But it's going to have to be an integer, consecutive integer. I think consecutive, you can start at anything, right? You don't have to worry.
Yeah.
So what do you think?
So could we round up the decimal?
Yeah, tell me. What do you want? Oh, wait. You don't want to round up to 50 because it says less than, right? You see that?
Yeah.
You can't. So tell me, what do you want? Look, yeah, round it down, right? You mean,
Yeah, what if we round it down to
like how much? What do you want?
maybe like this 49.
49 is the closest. Yeah, you got it, dude. Hey, I'm noticing something. This is your first number. The second number got to be 50. Is that okay? Consecutive. I've noticed something. You may want to change this. If your teacher is really technical, right? You don't want to write x equals. Erase the x equals. It's just bubble. Go back to all the x's that I've done here, because when you solved it, it was less than or greater than. It's not equals to from the beginning. Take out the equals to or the x even. You could just go ahead and ignore these even. You just last one is 248. Go ahead and do 48 plus 2. Show that only. Don't put x in anywhere if you don't want to. I don't think it matters. I don't think your teacher will care. But I'm just gonna point Yeah, some teachers are really critical. Hey, your x is not equals to, dude, because you're doing less than or greater than. That's the argument they can make. So therefore, just write the number, the answer separately, independent from the variable, and you should be fine. So just in case, I don't think your teacher will mind as long as you bubble the answer or something. So yeah, I'm being very technical myself here. I want to make sure that everything works out. Some teachers are. Anyway, okay, I think we're good. Next one. Yeah, sorry. 1 second. Let's continue. You got some fancy stuff that we have to deal with. All right. Two sides of a triangle have the same length. Okay, two sides. That means it's isosceles. Is that okay? Do you remember? In geometry? So two sides have the same. So I'm going to sketch out, stretch out one. You can do a flat one if you want. I'll do a stretch out one. It's kind of common. So I'll even mark them. The marking indicate congruent. They're congruent to each other. Yeah, congruent. The same length. So that's the marking. You can do double mark if you want in geometry, but let's do one. Maybe the next pair you can do two ticks, two tick marks. Right. Third side is 20 here. The third one is here, okay? Oh. So now that I've noticed that I read on, right? This picture is not ideal, so erase that if you can. You don't have to, but the way it's said that the third one is longer than the other two, therefore my drawing would not be correct because it's like they were longer than, right? Longer than my third one. So, all right, I'll fix it. How do I fix it? I'll flatten it, if that makes sense. See? The third one is now longer than the other two. Yeah, I'm being very, when you do math, I think you want to kind of like mix, what if you need to come back and check it, or you want to show it to your friend or explain it to someone? This will make more sense than the other drawing. I think you understand that. So it's 20 longer than each, look there, longer than each of the other two sides. What that means, I hope you're okay with this. It's like, that means the other side, you don't know what they are. You just call it X, N, whatever. But they got to be the same because they're the same two sides, same length. That's why you do X on both of them, XX. The third one has got to be 20 centimeter longer. So it's 20, like, plus it. See, now you see why you always want to add the 20, like not in the front, but put it in the back. Now, in wording of like decreasing, you better put it in the back. Like decreasing by 5, subtract 5. Decreased by 7, subtract 7. So it's mandatory that you subtract it from the back. And whatever's in front, variable numbers, whatever. Okay, this is it. The perimeter is oh wow, they're really pushing it. Still inequality. The perimeter meaning that the distance around, the triangle is no less than. So the perimeter means you're going to add them, right? So let's kind of set it up. X plus 20. You don't need to parenthesize this if you don't want, but that should show you that's like together as the side, or, one unit. Okay. The perimeter, you add them, is no less than 95. How would you write that? No less than 95 centimeter, but you don't need to put in the centimeter in your inequality, your setup. What do you think? No less than 95. No less than 95.
Greater than or equal to?
No, okay. Greater than for sure, or equals to. Man, that's tough, right? No less than 95. In grammar, yes, it's it's including 95. No less than 95. Yeah, it's including 95. Yeah, because if it were not inclusive of 95, not including 95, right? It would say something like something else. They're not going to phrase it like that. Greater than 95 or more than 95. They're not going to write it no less than. No, you got it, dude. This is pretty good, man. I'm glad you no less than 95, including the number. Okay, all right, we got this. At least how long? Now you might get like worried about, hey, what I do now? don't worry, just solve it, and you normally get the answer. But kind of look at the answer again a little bit after. Let's do the math, right? Combine like terms, 3x, x plus x plus x. There's no number in front of the parenthesis to distribute. It's just like 1. So therefore, just go ahead and ignore it. Like take out the parenthesis if you want. 3x plus 20. Let me be more technical here. 3x plus 20. I'm going to squeeze it so that the inequality is aligned. You don't have to do this, but yeah, in textbook they do this. They align it. 95. Okay. Subtract both sides by 20. You left with 3x greater than 75. I like this number because it's divisible by 3. Nice. Well, at least they're being generous here. So divide both sides by 3. So you're left with x greater than 25. Is that right? Side by 3. Side by 3. But
Yeah.
it's intruding into the next problem. Okay, then now let's interpret at least how long are the sides of the triangle. Well, the first one immediately is 25. Is that okay? Now we can use it. So these problems are great, well written. They're like, hey, you can't use this one until later on. Then you know when, here it is. So, okay, the first one is 25. Now you can do x. You don't have to worry too much, okay? I know I said something earlier. You can do x. And I would do that. Double check. Since your x is actually relating to these two sides, that means your first one is 25. Your second one is also 25. Your third one, you can show the work as 25 up here, scratch work somewhere. But only write it somewhere so your teacher sees it. So it's going to be 45. Is that okay? There you go.
Yeah.
That looks good to me. Now we get to actually use the the equals to the bar. All right, that should be done with that. 19. There are 3 exams in a marking period. Okay, a student received grades of 74 and 83 on the first 2 exams. Okay, this I already know it. This is very important. You get this every year. After you get one, you get every year. So you have to know how to set this up. What grade must the student get on the last exam to obtain the average marking of period? Okay, marking period of no less than 80. Here's the deal. This is actually generous. Later on, you have more than 3 exams. You have 5. You have 5, and then you have to find the 5th one. Or 5 already, you have to find the 6th one. It doesn't matter. You get more than just 3. Yeah, this one is being generous because you're learning it for the first time. So, but the setup will be the same. Okay, now I'm going to show you how you should set it up, and don't do anything fancy because you're in algebra now. Their method that is non-algebraic, which is messy, it's long. My students been doing stuff like that, by the way. I can prove it. I have a student who actually a grade below you. He's not allowed to use this setup, the thing we're about to write. So you're actually in the what do you call it? In the grade level where it's so good to do because it makes more sense when you see it right now. Okay, because when you try to do it like the level when it's not algebraic, it's bad. It's like you won't remember how to do it, and you do it the first time, second time, third time, but then later on, like next year or after the break or whatever, you forget. It's just messy. I'm not even kidding, dude. All right, 3 exams. You have to make them average no less than 80. 3 exam. Have a look, okay? I think you know it, but let me do it. How? You remember you average 3 numbers? You average when you average 3 numbers, you add them and divide it by 3, right? 4 numbers, you divide by 4. Add them up and divide by 4. So here it is. The first one, 74. The second one, 83. The third one, you don't know what it is, which is you're trying to find. Let me double check. Is that right? First 2. The last exam, which is the third one. There are 3 exams. So you add those 3. Here's the fancy part right here. Divided by the whole thing. Divided by 3. But then the part where we have to do inequality comes right here. We're going to put it right here, less than or greater than, whatever, right here. So no less than 80. I'll let you interpret that. What is that? No less than 80. What do you think? No less than 80.
Greater than or equal to?
Yes. Once again, this is grammatical. Yes. Good job, dude. Now, I'm not worrying too much about this, but the solving, we're going to do it. I think you might have seen it, maybe. If not, this may be the first time. It's quite fancy. It's actually not a big deal. It's not even a big deal because your algebra has been very, elevated, like quite advanced. So this one shouldn't be a big deal. But I want you to look at this carefully. Okay, this thing is you're going to see this over and over. You're going to have to find your, you're going to do this on your own, not even like for math. For a math problem, right? You're going to actually want to figure out, hey, what do I need to get an A in the class? This is how you do it. Everyone does it exactly like this after you learn it. You said it, you're going to have like 4 exams in the whole year, school year, or in college or whatever, right? 5, maybe 6. You're going to do exactly this. What do I need to get on the last one to get me an A? You teach you scale it greater than 90, then you make it greater than 90 right there to get an A. Well, you're going to do this on your own. Your teacher won't even tell you, hey, this is how you do it. You're going to have to actually do this on your own. I've never seen teacher tell you how to actually find your own average. So that's why you learn the algebra to do it. So, yeah, but normally they scale at 90 and up to get an A, okay? So 80 is like, a B and above. So this one, they didn't say anything about the grading, letter, A, B, C, or whatever, but it seems to me like at least a B. All right, let's do the math. How? You can add them. You can add them later if you want. Let's add them to be neat. What is that? 7. What is that? 15 plus x. 157 plus x divided by 3 greater than 80. Yeah, just be neat here. Yeah, combine like term bit and bit here and there. Now the next step: multiply both sides by 3. You can parenthesize if you want, like this, like that, or even here. Okay, but I'll try to keep it neat. I'll dot it. You can parenthesize it. I think actually the textbook will parenthesize it. I'll go ahead. I'll do it here, and then I'll dot it here, or just all right. I'll just parenthesize it here. It doesn't matter. You can parenthesize both of them. Sorry, I'll do that. I'll do this one. So again, let's see what happened here. 3 cancel here. If you tell me if you're okay with that, like over 1, 3 cancels there. That's how you want to do it. Then all you have left is 157. You don't need to keep the parentheses anymore. And then greater than or equals to stay the same. 80 times 3 is 240, like that. So far. Continue. Subtract both sides by 157. X greater than, what is that? 3, 8. Yeah, because you borrowed 1 from here, right? So 0 with 3. And you borrowed 1 here. You're left with 13. Yeah, it's 83. So greater than 83. All right. This is the answer. So you need to get at least or exactly 83 or above for you to get at least an 80. I guess overall average. Yeah. There you go. That's the answer, dude. As simple as that. You just bubble this and you're good. Yeah, if you've never seen it, this is the typical thing that student would do to find out their grades on their own. No word problems, nothing relating to word problems, but of course, they learn it from here. Fancy stuff, dude. Right, next one. 20. So what, I want to make sure. All right, a pair of consecutive integers has the property that is 6 times the smaller. It's less than 5 times the greater. Dude, this is like algebra stuff that I remember. Like, what? I remember learning the first time. All right, What do you think? A pair of consecutive integers, right? I think you're good with that. So x and x plus 1, is that okay? Let's just kind of break it down a little bit. A pair of consecutive integers, not even or odd, so it's just going to be plus 1, not plus 2, has the property. What does that mean? Has the property. Has the property of 6 times the smaller. Okay, well, I don't know. This is part of the equation. That 6 times the smaller. Okay, let me add this first. Okay, let me add this first. But this is not. I'm not setting up the inequality yet. I'm going to add them, and I'll keep it on hold to x plus 1. Okay, I'll keep it on hold there. All right. It has the property of 6 times. I'm going to start right here. 6 times the smaller. 6 times the smaller. Okay, I'm going to do 6x. Oh yeah. Don't forget, this is your first, this is your second. I don't know that we're adding yet. Oh, you know what? Let's don't do that. Okay, backtrack, erase. We don't, it doesn't say we add them or anything, so I'm just going to list them. Sorry about that. So here's my first, here's my second. Oops. This is my first, this is my second consecutive. My first and consecutive. So just let it on the side. Normally they say let your first consecutive to be this, your second is that. So, but I'll place it there on hold. So yeah, put it on the side. Now we continue here. 6 times the smaller. Well, x is the smaller, right? Is that okay? Go back and look here. X is the smaller. It's less than 5 times the greater. Ah, I get it. No, there you go. You don't really mix them up, together anywhere. Just write it out to the side, and then look at it. Each, wherever. That's it. This is what you do. So let's solve it. Distribute. So 6x less than 5x. Hey, are you okay, Alex? Yeah. Have it here for you to eye them so that you know how to use them. All right, let's continue. Yeah, don't forget our inequality. Remember, I was encouraging you to actually, get the variable on the left side if you can. Subtract both sides by 5x. So you're left with x less than 5. Okay, now we interpret. All right, less than 5. Find the greatest such integers. Well, we cannot use 5 once again. There you go, right? We cannot use 5 because it's not including, no bar. It says less than 5. So we cannot use 5. So, let's tell me the first number. What do you think?
4.
4 for sure, but let me think. Smaller, less than 5. Man, 6 times smaller. I want to use 5, but then if we use 4, like when you say 4, that seems to be the first one. Your instinct to say the second one will be 5. You know what I mean?
Yeah.
But let me think here. Man, you see, we're going to use 3 and then add 1 to it to be 4. Okay, let me see. I'll list them. These are the one pair. If we use 3, which is less than 5, and plus 1 to it, it'll be 4. You get it? Like, I know it's like you're worn out. Worn out by now, right? Yeah, one more and we'll just set it up. But wait, so I chose 4. I know we're trying to go by what they say here, right?
Mm-hmm. Yeah.
It's 4, 5, or 3, 4. Let me think. 6 times less. You know what? Let me test it out. Dang it. Let me test it out. If I plug in x being 4 in here, it will work. I know 4 will work. 3 will work. Like 4 will work. How do I know? Because you set up the equation for it to work. The answer is you got x less than 5. Therefore, 4 is going to work. If I plug it back in here. Now, why am I plugging back in there? It's because the condition they gave you right here, starting right here. The condition says 6 times the smaller blah, 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 which is this inequality right here. What that means, 6 times, let me read it, 6 times the smaller less than 5 times the greater. So if you ever check the answer, it better be less, it better be true. What do you mean by true? This side better be less than that side. Get it?
Yeah.
So let me test out the 5. Let me test out the 5. 6 times 5. Is this true? My question here. The 3 will work. I think you understand why, because it says, anything less than 5 will work. I want to test the 5. I want to test the 5 and see. 5 times 5 plus 1. I'm plugging in the x being 5 right here and right here. 30 is 30 less than, or would it be less than this here? So that's going to be 6. 5 times 6. Oh, it's not true. Yeah. That's why, see, I want to check it. So that means you have to use 3 and 4. Is that okay?
Yeah.
Yeah. If your teacher ever, tell, hey, no, that's not true. You do 4 and 5. But why? Because, you pick the first one to be 4. The next one, you add 1 to it. It'll be 5. But it says no 5, dude. Right? That's why. And I checked it. It's true. Here's 30. 30 is not less than 30. That's false. That's why it's not true. You cannot use the 5. So the answer better be 3 and 4, not 5. Is that okay? I hope you're okay with that. Now, your teacher may say otherwise, but you can prove it by you plugging it back in. Why do I think that? Because I think your teacher would do that. I think your teacher might think that's the answer, unless they have the solution and everything's worked out. Sometimes teachers are stubborn, okay? So we already checked it. Like I'm making negative comment about your teacher. I don't mean your teacher specifically. I've had experience with other teachers who actually had problem with that. Okay, I can't even erase that, dude. All right, last one. Just set it up at least. Sorry, I know we're wait, 1 second here. Get it smaller here. Sorry. No, I meant the eraser. Sorry. This is like yeah. The downside of using the app here. But it's much more convenient for me. All right, the sum of 4 consecutive. Wow, here we go. We're going 4 consecutive. Okay, I don't want to write on the side. I'm just going to write it down. Consecutive integers, right? Okay, here we go. First, I'll group them this time to emphasize it. Second, third, and fourth. Tell me if you agree. I know it's like, here we go. We're going more than 3, more than 2. Sum of 4 consecutive integers decreased by 18. I want you to help me for the rest of it. Wait, did I do this right? No, it's consecutive integers, not consecutive even. Sorry. Right? Yeah. I got stuck on even and odd here. So it's x plus 1, x plus 2, x plus 3 for the other ones. There you go. 4 consecutive integers. So I see they're actually kind of have you shell down a little bit. Don't make it too harsh, like make them blow it up. But tell me the rest. How do you do it? Decreased by 18 is greater than twice. What do you mean? Decreased it by 18?
So, like minus 18?
Yes. And then continue. Yeah, you want to put it in the back, right? Yeah, this is where it's kind of like mandatory. Is greater than, how, continue. Greater than, is it okay? Greater than? Twice the smallest of the 4. Twice the smallest of the 4, that means 2x. The smallest one we chose is x. Is that okay?
Yeah.
Okay, let's solve. And then we'll be good, right? So okay, add like terms. 3, 1, 2, 3, 4. 4x. 3, 6 minus 18. 3, 6, 6 minus 18. So that's minus 12, negative 12, greater than. Is that okay? Double check my math there. 3 and then 6 here, and then subtract 18. So it's negative 12 or minus 12. 2x. Okay, continue, solve. Add both sides by 12. simultaneous work here, okay? Subtract both sides by 2x. I hope you're okay with that. You can chill out and do step a bit by bit if you want. So that this cancel, you're left with just 12 on this side. Yeah, if you need to do whatever you need to do to make it clean, you can do it, okay? But I'll do it this way so you see how I would have done it. Like that, so forth. And then divide both sides by 2x. 2. Then x is going to be greater than 6. Okay, we're going to have to interpret the answer. Right? So it says, and then we'll be done. So what are the 4 smallest possible integers? Okay, so it just for learning reason, the last one is at less than 5. You better want to follow it to the T. So we don't use that 5. Your teacher may use the 5. That would be wrong. That means that the first number better be greater than 6, right? Consecutive. So it should be 7. Is that okay? 7,
Yeah.
8. Yeah, 7 greater than 6, 8, 9, 10. That should be correct. I'm pretty sure. Okay, that's it. 4 smallest such integers. It doesn't say you're going to do anything with them. That's it. I know